This is for Year 12 Methods. It is the question 4 in the 2019 Functions Application Tech Allowed SAC. So in question 4, we're considering a hyperbola where we know all of the values. Then it goes over to the page to consider the hyperbola in terms of an A in the numerator. And then it changes further in the question when we're considering B and when A equals -1, when A equals +1. And we're looking at intersections of the hyperbola with its inverse. So I'm looking for its inverse. So here I have my hyperbola. I'm going to make that equal to y, make it equal x. I'm going to replace the x with y. And I'm going to solve for y. And that gives me this. I'll accept this answer or these two forms as well. Now, if I was to consider these hyperbolas, this one, and then this one, and the intersection point you will find will be these values here. If I took this component only, not the y equals, and then did intersection G solve intersection, then I find that that's -2.56, -2.56, and positive 1.56, 1.56. However, I need exact answers. So I come back up here to main, and I know that these are going to intersect also with the line y equals x, because you will notice that the line y equals x also goes through that intersection point. So I'm going to make this with an x there, and solve for x. And gives me these two x answers. And of course the y coordinate will be identically the same. So I have -1/2 minus the root 17 on 2 and -1/2 minus root 17 on 2. Okay, now when the question changes, I've now got the inverse. So if I come back up here and instead of putting a 2 on top, I have an A on top. And I find the inverse. There is an expression for the inverse. And I'm finding the coordinates where the inverse, so if I take the inverse and I set that equal to x and solve for x, I get these two expressions. So these are my x-intercepts. It's -1/2 minus the square root of 4a plus 9 on 2 and minus. Okay, find the values of a that give two intersection points. Okay, I'm going to have two intersection points. If the thing inside the square root, so the 4a plus 9, if that is bigger than 0, then I'll have two intersection points because I'll have two positive square roots. And for one intersection point, that means the discriminant equals 0. And it's equal to -9 on 4. And when it is less than 0, then I'll have no solutions. And that's when it's less than -9 on 4. Okay. Over the page, we then have a parameter b involved. And that parameter b is up here. So if I do the same steps, I'm going to have, I've got plus b, so I write plus b. And I There is the expression of my inverse. So I copy that, come down into a new line, paste, make it equal x, and solve for x. So find the intersection point. Okay, now in this situation, I have a condition that a equals -1. And that gives me this. Now, if I explore the discriminant of this, then I will have two intersection points when that bit is bigger than 0 and solve for b. So when b is less than -1 or when b is bigger than 3, I will have two intersection points. When this is equal to 0, that is x equals -1 or 3, you will have one intersection point. And when that is less than 0, you will have b between -1 and 3. If I make a equal to +1, then I get this expression as my discriminant. And if I look at -2b plus 5, then I get no solution for negative being less than 0. I get no solution for being equal to 0. And of course, I'm going to get all solutions for b. And that's what b equals b means. B is all real numbers for when we have a is equal to 1. So it's all real numbers. Now, in actual fact, you can't have x equal to 1, b equal to 1, because if b equals 1, then that's the asymptote, and we can't actually intersect on the asymptote. But of course, there's no solution, no solution.